Welcome back to Infinite Cosmos. Picture Earth wrapped in an invisible shield that bends charged particles from the sun. That shield is the magnetic field, and it's born in the molten iron of the outer core. The engine is a geodynamo. Convective flows of conducting fluid generate electric currents, and those currents produce magnetic fields. In physics terms, this is Magnetohydrodynamics, the coupled Navier-Stokes and induction equations. So fluid motion and electromagnetic induction are inseparable. Small changes in flow can produce large changes in the field we measure at the surface. What do the measurements tell us? Modern satellite magnetometry, especially ESA's swarm constellation, maps the field in microteslas and tracks its year-to-year change, the secular variation. The global field at Earth's surface is roughly 2565 UT, depending on location. Over the last few centuries, the average strength has declined by a few percent. Superimposed on that slow trend is a pronounced regional minimum called the South Atlantic Anomaly. A broad patch of reduced field strength centered over the South Atlantic and parts of South America. Swarm time-lapse maps show the SAA has expanded and shifted in recent years. That is a measured quantitative fact, not speculation. Why does the SAA exist? The core answer is redistribution of magnetic flux by core flows. The induction equation, NOR BT ER AX, UXB plus C2 BX, tells us that the time change of the magnetic field, or BC, depends on advection by velocity, or bavardioudres, and diffusion with magnetic diffusivity, A cosirnes. In the outer core, where magnetic Reynolds numbers are large, advection dominates and vortices or jets can concentrate or deplete flux locally. Numerical geodynamo simulations that solve these equations in a rotating spherical shell reproduce SAA-like features, confirming that internal core dynamics explain the anomaly. What are the consequences? The primary short-term impacts are technological. Low Earth orbit satellites passing through the SAA encounter. Higher fluxes of energetic particles, increasing the probability of single-event upsets. Bit flips, transient anomalies, and occasional hardware faults. Engineers mitigate these risks with radiation-hardened components. Error-correcting memory, redundancy, and operational scheduling to avoid sensitive tasks during SAA transits. Astronauts receive slightly elevated doses during passes, but mission planners include that in exposure budgets. For people on the ground, current evidence shows no immediate health threat. Paleomagnetic records indicate that past geomagnetic excursions and full polarity reversals occurred without causing mass extinctions. How worried should we be about a global collapse or imminent reversal? Timescales matter. Regional changes can occur on years to decades. A measurable global decline unfolds over centuries. A full polarity reversal takes thousands of years. The Geodynamo is chaotic, so predictions are probabilistic. Scientists run ensemble simulations and continuously update forecasts as new satellite data arrive. Some model ensembles show continued SAA growth, others stabilization. None give a precise date for a reversal. What should we watch for? Continued monitoring of secular variation, quantitative maps in microteslas, and changes in the SAA's area and center. From an engineering perspective, improved radiation hardening and adaptive operations are the practical responses. From a science perspective, better core flow inversions and higher resolution geodynamo models will shrink uncertainties. Bottom line, Earth's magnetic field is dynamic. Parts are weakening regionally. The South Atlantic anomaly is real and growing. But this is an internal, fluid-driven process with manageable technological impacts and no evidence of imminent catastrophe for life on Earth. Scientists and engineers are already adapting. Continuous observation and improved models are our best tools. If you want a data walkthrough of swarm maps or a math-light derivation of the induction equation next, tell me in the comments. Subscribe to Infinite Cosmos for more data-driven space explainers.